Welcome to section 8.3, part 2, translating and shifting functions. We're going to work on a few graphs of hopefully some familiar or soon to be familiar functions, these three, and look at what happens when we shift them, what happens to their graphs, and how we can control it and predict it. So let's get started with getting acquainted with some of the familiar shapes of these graphs. If they're not familiar yet, that's okay. They will be soon. So if we wanted to figure out what a graph looked like, one thing we could do would be plot some points. So we could put in points like, say, I don't know, -2. And when I square -2, I hope you square it the right way and get a +4. So there's your point, -2 and +4. How about another one? Maybe -1. Okay. And then 0. Okay, 0 squared is 0, got that. And then after that, 1 squared. Well, 1 squared is 1, and 2 squared is 4. So you get this shape that's being traced out, and that shape should be something that's familiar or soon to be familiar. That's the shape of a parabola. Now, the question is, well, what if we had an equation similar to that? So hopefully you've got a handout, or if not, then you can take notes from here. What if we looked at a graph like this? Y equals x minus 3 squared, or y equals x plus 3 squared, like this one down here. Are those graphs going to be wildly different, or are they going to look similar? Maybe they're just shifted versions of the graph that we started out with. So let's find out. Now, there's a couple ways you can do that. You could do it by plotting points. I really don't want you to do that. I want us to use some technology and do this a little bit smarter. So if you want to take the time, go over to a website called Desmos, and you can kind of follow along that way. So let's see, desmos.com. I don't think it'll ask you to sign in, but it may. And we can type in our own equations there. I'm going to do it back on this graph here. So let's take a look at some other functions. For instance, y equals x minus 3 minus 3. And then if you hit the shift key right above number 6, allows you to get the up arrow. You can also hit this key down here at the bottom and hit the squared key if you want to, plot something with the power of 2. But what do you think that's going to do? Is this graph going to look a lot different than our other one? I'm guessing not. In fact, I'll give you 4 choices. It's either going to be shifted up 3, down 3, left 3, or to the right 3. So which one do you think? Well, let's do the big reveal here. You ready? Got it? All right. Well, look like it has shifted 3 places to the right. Okay. Kind of surprising. I mean, I remember looking at this result when I first started teaching and going, oh, that's kind of odd. I expected it to go to the left because you got that -3 there. But keep in mind what happens with the graph of the parabola. You get this point here when you square 0. That's the lowest it could be. So you're going to ask yourself, well, what value of x would make this 0? And that value is 3. When I put in a 3 there, I get 3 minus 3 is 0. So, okay. So the point that was here on this graph is now here on this graph. So in effect, that got shifted to the right by 3. Cool. All right, well, what else can we look at then? Kind of following along with this. Well, maybe you can make a prediction now for x plus 2 squared. Now think about this. When we did x minus 3, I got shifted to the right by 3. What's going to happen if I put in, say, x plus 4? All right, let's shut off this other graph here for a second. And Help me out if I could find my cursor here. Oh, here we go. So we've got y equals, and let me just double check this one here, x plus 2 quantity squared, x plus 2, and let me shut this graph off for a second. Now, I'll demonstrate the keyboard here. If you wanted to get the squared key, something to the second power, just hit that. Should put that up there for you. Oh, there it did for us. So hopefully you predicted that. That shifted to the left by 2. Let's fill in a couple things on our sheet here. So comparing the graph of x squared with the graph of x minus 3 squared, the second graph was shifted to the right by 3. And with respect to the second of these examples, comparing those two, the second graph, x plus 2, was shifted to the left by 2. So, okay. So a couple shifts that we're able to accomplish. That's nice. And what's also nice is that eventually when you start working with this enough, you'll be able to look at an equation and predict what its graph is going to look like. You're saying, oh, okay, yeah, I know what that's going to look like. And that's a great skill. That's the skill that I want you to have when you come out of this section. So let's try some more. Moving down the list here, let's look at y equals x squared and y equals x squared plus 3. While I cursor over to my graphs, any predictions? So we got y equals x squared, and let's shut that off. Come on, there you go. Y equals x. You can hit the square key, or again, like I said, the shift key. Let me shut off the graph so that we can do a surprise here for ourselves. Squared plus 3. So again, you've got 4 choices. It could be up, down, left, or right. Now I'm hoping that you can see some of the differences between these two. Here, what's being squared is inside the parentheses, right? And down here, what's being squared is, or what we're adding to that x is not part of the parentheses. We're not squaring that. So it's just x squared, and then we add 3. So there's a difference between these two. Which way do you think this is going to get shifted? Hopefully you've narrowed it down to up 3 or down 3. In this case, it actually happens to be up 3. And you can see that. So the red graph is a graph of y equals x squared. Here's a graph of y equals x squared plus 3. So that one got shifted up by 3. It's a little different. The vertical shifts are kind of what you expect from them. The horizontal shifts are kind of opposite of what you expect. So this one got shifted up by 3. There we go. So that moves us down to this next one. And again, I'm going to ask you to make a prediction here. Y equals x squared minus 4. See if you can't predict in your mind what's going to happen when I change this. And I'm going to cheat just a little bit. I'm just going to make that a minus 4. So compared to the graph of y equals x squared, how do you think this graph is going to be shifted? Okay, so if you said down 4, then kudos to you. You nailed it. That one gets shifted down by 4. So let's slide that in here. Down 4. Nice. So what I'm going to do next is do kind of a combo. All right. We're going to do a couple shifts. Now what we've seen is left and right, up and down. How about if we put a couple of them together? We don't have to just do one kind of shift at a time. We can do multiple shifts. So that'd be this next one down here, here, and here. So there's two shifts. Remember what goes on inside the parentheses here, that's going to be a horizontal shift. What goes on outside the parentheses, that's going to be a vertical shift. So while I navigate over to Desmos, see if you can't figure out what those shifts are. So that'd be y equals x plus 3. Shut that off. Hit the square button, and then -1. So did you get both shifts? How about the first one inside the parentheses? Anyone on that one? Yes, at the back of the Zoom with the orange hair. Okay, beautiful. Yes, to the left by 3. Good deal. And then you want to finish the other one? All right, left by 3 and down by 1. Perfect. Let's take a look at that and see if that's true. I'll turn this on. And bam, looking good. To the left by 3 and down by 1. So what happens is that these things become very, very predictable. And you can look at these graphs and figure out how they're shifted. So let's write that down here. Left 3 and down by 1. All right, here's a new little twist for us. Let's take a look at this graph versus this one down here. The graph of y equals x squared versus the graph of y equals negative x squared. So there's probably several different things you could think of in terms of how this is going to change the graph. And let's just kind of see what happens here. Now, if you want to see it kind of a numerical way, we can do that, I think. Let's see, can I add? Yeah, I can add another column. I can do minus f of x1. And what happens when you look at negative x squared, that is, if I put a negative there, then all your values, all your y values get multiplied by a negative. So instead of opening up, what's this graph going to do? You said opening down, then good on you. Y equals negative x squared. So what this does is it causes a reflection around the line of y equals 0 or around the x-axis. It just flips the graph upside down around the x-axis. So, wow, lots of cool things we can do with the graph of parabola. And parabolas have lots of nice applications too. In fact, one that you may see right here in the Great Lakes state, if you go up north, you might see, not the Mackinac, let's see, I don't want the Mackinac Island Grand Hotel, I want the Mackinac Bridge. There we go, Mackinac Bridge. And let's take a look at some images. Yeah, this is the shape of a parabola. Once the engineers laid that deck there, that stretches the cables into a nice parabolic shape. So pretty cool. Lots of other applications. You'll hear me talk about them later in the semester when we go through chapter 13 on conic sections. But let's finish this one up. There's kind of a couple things that I want to highlight for us here in terms of translating functions. And it's kind of in keeping with the handout here. It's asking you what happens with the H, what kind of translation does that cause? What kind of translation does the K cause? So we've seen a couple of these. H controls the horizontal shift. That one right there. controls the horizontal shifts or shifts vertically or horizontally by H. How about the K? The K is going to be a vertical shift. Vertical shift of K. Nice. So the thing that you got to remember is that that shift in the horizontal direction is going to kind of be opposite of the sign here. So if I have a -4, it's going to be shifted to the right of 4 instead of what might feel like it should be to the left of 4. And vice versa. If this is a +6, instead of shifting to the right by 6, it's going to be shifted to the left by 6. The vertical part is just what it seems. +4 means up 4, -6 means down 6. So nice. One of the things I could do is ask you to reverse engineer some of these things. And this is a good quiz test type problem. That is, I say, all right, what's the equation of a parabola that's been shifted to the right by 3 and down by 5? So there's two things here. We got to do the right by 3 and the down by 5. So let's see about both of those. So it's going to be y equals, now to the right by 3, that's going to be something squared. That 3 has to be in here. Well, what's the sign? Yes. Person up front here. All right, good job. -3. And then down by 5 would be -5. Well done. Okay, you can check these things. You can check them on Desmos. You can check them on your graphing calculator, whatever works. And in a little bit, I'll get around to showing you how to do some of the stuff on the graphing calculator. For now, pause the video for a second if you would, and give yourself this one. See if you can shift a parabola to the left by 6 and up by 15. Can you come up with the equation that does that one? Spoiler alert, the answer is coming if you haven't paused the video. So to the left, well, our horizontal shifts are going to be coming from what's inside the parenthesis. So it's an x and a 6 squared. Hopefully you put +6. So x plus 6 squared, and then up by 15 would be +15. Nice. What I like about this last one is that it's not exactly very easy to double check yourself on Desmos and the graphing calculator. Basically, it's asking, do you know and understand these things? So lots going on with this last one. One new twist in this is that in addition to everything else, I want it to open down. So I'll tell you what, we'll start with the open down part. And oops, let's see. Oh, there you go. All right, sorry if you're getting dizzy a little bit there. So with the open down part, that comes when you use a negative out in front. So I'll just put that negative right out in front like that. Don't distribute that negative. It only makes it open down if that leading coefficient or if this negative is outside that parenthesis like that. So it'd be negative x. Now I'm shifting to the left by 91. So it's going to be a plus 91. And down by 57. Well, that's going to be outside the parenthesis. And the vertical shifts happen in the same direction as what you might think. So a minus would be down, a plus would be up. There you go. That's a quick 3 or 4 points on an exam. That's a nice little problem there. Cool. Questions on that so far? Doing okay? All right. All right. Well, this teaching from home stuff is kind of tough. I wonder if teaching or working from home is a good idea for other people. What do you think? I don't know. Let me know in the comments if teaching or working from home is a good idea for everybody. If not, hey, hopefully we'll be back face to face soon. Let's move on. Talk about a different type of graph. And that next graph, let's see. I think we're going to do the cubic function. Well, let's take a look at our handout here. We practiced some of those. Let's work on the absolute value a little bit, and then we'll return back to finish these problems. And then we'll finish up with the cubic function. So the absolute value is next. There we go. There's our absolute value function. So like we did with the previous one, we're going to investigate this initially just by plotting some points. I would imagine that you can take the absolute value of a number pretty easily. It's just really giving you the positive part of a number. So -1 would be our next one. Then 0, the absolute value of 0, 0. Absolute value of 1 is 1, 2. And you can keep on going. 3. Let's type in -3 here just to get some symmetry. But you see kind of a similar shape to what we saw with the parabola. The difference is that at this point here at the origin, the vertex of the parabola, if we were working with a parabola, so it's vertex, or if you want to call this a vertex, it's great. This vertex is going to be sharp. It's going to have a sharp corner or a nice point there, as opposed to something nice and smooth like you get with the parabola. Now, I don't know if you're going to be graphing these things by hand for me in this course or ever, because I don't really like graphing them. But one thing I do get a little bit picky about is that I want you to make sure that this graph is nice and smooth. This one has a point on it, and it should. So let's play around with this one. The same thing is going to happen here that happened with the graph of the parabola. We can shift this up, down, left, and right. And it should behave much the same way. So we'll start out with, well, let's see. Let's take a look at the handout. The absolute value of x plus 2. Now think about the parabola. If this was x plus 2 in parentheses, what kind of a shift is that 2 going to cause? It's going to be shifted to the left by 2, to the right by 2, up by 2, or down by 2? Well, when we're working with the parabola, when we change things inside the parentheses, that causes a horizontal shift. Now for our absolute value, when we change things inside the absolute value, it's likewise going to cause a horizontal shift. So let's see if we can't figure out what that one looks like. Go back here, we'll graph y equals, and if you can't find the absolute value keys on your keyboard, just hit the little keyboard icon, and there's your absolute value. Absolute value of x plus 2. So if you said it got shifted to the left by 2, hey, good on you. That's exactly what happened. There's your vertex of this graph. It was at 0, 0. Now it's at -2 and 0. Perfect. So that got shifted to the left by 2. Let's write that in. Left by 2. Good enough. How about this next one down here? Tell you what, I promised that we would learn how to do some of this stuff on the graphing calculator, we will. Let me do it here. So this is your basic TI-84 graphing calculator. It's going to look very similar on TI-82s or TI-83s. I don't think anyone would have a TI-82 anymore. So I'll click the Y equals key. That gives me the equation editor. I want to graph the absolute value. Now, if you're not familiar with this, then let me show you how to find the absolute value. You're going to hit the math key and then cursor to the right once for number. And the first thing you see is ABS. That's your absolute value. When you press that, you get the absolute value symbol, graph the absolute value of X. And there we go. Now my window, where I'm going to see my graph, is set up to be the standard window from -10 to 10 on the x-axis, -10 to 10 on the y-axis. So I'll hit graph, and there you go. There's my graph. Let's compare that to the graph of the absolute value of x plus 1. So we're going to do this next little bit here. And maybe you can kind of predict what you think is going to happen with this one. So go back to your equation editor, hit the Y equals key if you haven't already. Come down. Go to math. You remember where next? Over to the right once for number, press enter. Absolute value of X, and that's this key right here. And then you need to hit to the right arrow to leave the absolute value and then type in your +1. Beautiful. Now, if you're kind of losing track of some of the things I did, you can see the key history that I have here down at the bottom. You can see exactly what keys that I've been hitting. Let's press the graph key now, see what that looks like. And it's not quite as pretty as Desmos, but I think it still gets the job done. This has been shifted up. You can see it's been shifted up by 1. So let's take note of that. Up by 1. Beautiful. Now this next one down is kind of a combo job. It has 2 shifts in it. So let's see if we can't figure out what's going on with that. 2 shifts. And I'll give you a second or two to think about it. Pause the video if you like. See if you can't figure out how this graph has been shifted compared to the graph of just the absolute value of X right here. So how's that graph going to look compared to this one? All right, so let's plug that in here. Got the graph of the absolute value of X. And I'll shut this one off and change things up. So it's going to be a +4 and then a +3. So the graph of just that first part, if I didn't have that +3 there, how much of a shift would that cause? In which direction? Hopefully you're saying to the left by 4. If you did, that's awesome. And then the +3 should shift it up by 3. So basically, I should have a point. In fact, I can plot where that point should be. That vertex should be at -4, 3. That's where the vertex of this graph should be. Let's see if I hit it right. One more time. There we go. Beautiful. Exactly where we thought. Okay, so again, we need to take some notes here. So that was shifted to the left by 4 and right, there's going to be up 3. Nice. Okay, Now we got one last one for this kind of set of problems. And I guess the first thing I want to draw your attention to is this little piece down here that I've got a negative. Now, what happened when we graphed the parabola and there was a negative out front? That's right, it flipped upside down. So this is going to flip upside down, but then what? What happens with that -4 there? Does that flip and become a +4, or does it become a shift to the right or to the left? What happens with that? I'll tell you what, let's just experiment. Let's see what happens. I could tell you, but that would end the suspense. So let's go back to our graphs. I'm just going to add a new graph in here. So do y equals, I'll find my absolute value down here. Absolute value of x. You know what? I probably should have typed in the negative out in front first. So let me back up, put the negative there. And you can see that the graph has been flipped from what we started out with, the graph of just the absolute value. How about that -4? What's that going to do? It should shift it down by 4. Let's see that it does. So if it shifts it down by 4, let me make my prediction. I should have a point at 0, -4. That's where I think the vertex of my new graph is going to be. So let's see if I'm right. -4. Looking good. Looking good. This is exactly what we expected. All right. So that's showing you that what's happening with this graph, behaves similar to the graph of the parabola. You just got to know that basic shape, and then you can be able to translate this left, right, up, down, and flipped. So this one is flipped and shifted down 4. Okay, one last function to know, and then we'll maybe wrap it up with a little bit more work on parabolas. The last graph that I'd like you to be familiar with is the graph of the cubic equation. So let's take a look at that. So that one's here. We're going to do exactly what we did with the previous couple graphs. We're going to start by plotting some points. I'll plug in a -2. And when you cube a -2, you get a -8. And you see that one point down at the bottom. What should I plot next? All right, good on you. -1. -1 cubed is -1 times itself 3 times. Those negatives don't disappear like they do with the squared functions. And then 0 cubed is 0, 1 cubed is 1, and 2 cubed is back up to 8. And this function kind of snakes its way through the origin, which is the point 0, 0. Gives you something like that. But now that you know that basic shape, we should be able to shift it around much like any other function that we dealt with here. So let's see which functions we're going to work with. The first one is x cubed plus 2. Now the thing to notice is that that plus 2 is not inside of parentheses like it is with the next one. With the next one, that -1 is in the parentheses. So that should cause a, yes, horizontal shift. This one should be a vertical shift, right? So let's see what happens when I graph that one. So let's graph y equals x. Now, if you're wondering how to get the cube, again, you can hit that Shift 6 key to get the cube that way. Or if you wanted to, you could also type in, hit the keyboard, and then choose this option. That'll put something up in the exponents. X cubed plus 2. So what happened to the graph? Was that what we expected? Yes. That's shifted up by 2. up 2. How about predictions for problem number 36 here? How's that one going to get shifted? Get your bets in, get your bets in. All right. Y equals parenthesis x minus 1 raised to the 3rd power. That one got shifted to the right by 1. How can you tell? What you can do is you can look for similar points. Here's a point at 0, 0. On our new graph, that point is at 1, 0. So it got shifted exactly 1 spot to the right. Nice. Okay. Let's put a couple together. With this one, give you a good test. Now, do you need to be able to imagine exactly how this thing looks? No. What I'd like you to be able to do is just look at that and figure out, well, how has that been shifted? Now, inside the parentheses causes a horizontal shift. So we'll look at that. And then outside the parentheses causes a vertical shift. So we'll take care of both of those. All right, so x minus 3 cubed minus 2. Oh, and I guess I forgot to write in what would happen with the last one. That got shifted to the right by 1. Right by 1. All right, and I'm going to cheat just a little bit. I'm just going to do a minus 3 and a minus 2. So minus 3, that's just shifted the graph to the, yes, right by 3. And then, well done, down by 2. Yeah, I'm impressed. You really know your shift. Okay, did you catch that? All right. You can see that this point here, 0, 0, has been shifted over to this point right there at 3, negative 2. So the right by 3 and down by 2. It's exactly what we expected. So right by 3 and down 2. For the last one, what's the first thing you should notice when you're trying to figure out what this graph's going to look like? All right. Hats off to you if you said, oh, there's a negative out front. That negative is going to flip the graph. So let's take a look at what happens when we do that. So I'll shut this off. And I'll get rid of these points here because they're distracting. So this is the graph of y equals x cubed. If I had the graph of y equals negative x cubed, you can see that it's just a reflection. It's just been flipped around the x-axis. Now, our graph is a little bit more than just that. So let me shut that off. It's y equals negative x cubed plus 1, or negative x plus 1 cubed, I should say it that way. Y equals negative of x plus 1. And we got to come out here and put in the cube. So I'll do it this way. Click the a to the b power, put in the cube. Now, does this negative change the way it gets shifted? Right now, what's inside here seems to suggest that it gets shifted to the left by 1. But with the negative outside, does it get shifted to the right by 1 because they cancel each other out in some way? What do you think? Let's see if it matches your expectations. So which way did it get shifted? It gets shifted to the left by 1, which is this. And what that's saying is that this number out front doesn't affect the horizontal shift, which takes place inside here. Okay, You need a little more practice. Let's finish up the top of this. So this one was flipped. And shifted to the right by 1, or left by 1. And these last couple, I'm not going to take the time to graph these. Pause the video and see if you can't just nail all these. See if you can't make these predictions. How has the graph been shifted just by looking at these graphs? Okay, so inside the parentheses, I've got a -6. That's going to cause a horizontal shift to the right by 6. Next one, that -5 is not in the parentheses. It's just the squared function -5, so this is going to be shifted in the vertical direction down by 5. Combination job here for you. 2 shifts. First inside is going to be shifted to the left by 2, and then down by 1. And last but not least, x minus 4 squared plus 3, that's going to be shifted to the right by 1 and up 3. Okay. Hope you did well on that. One parting thought / reminder, when you do these shifts, you can still look at domain and range. So let's look at, say, the last one of these, x plus 2 squared minus 1. And take a look at that and determine its domain and range. So let's see. Back over to here. So it'd be x minus 2 squared. And what was the rest of it? Plus, oh, minus 1. Thank you. X plus 2 squared minus 1. Let's get rid of this other graph here. I can keep that one. So it's left by 2, down by 1. Now its domain is going to be everything. This graph continues everywhere in both directions. But what I do want to point out is the range. The bottom of the range is -1. So the range for this is going to be y is greater than or equal to -1. You use the equal to because this actually gets down to -1. It's not like there's a hole in the graph there. So y is greater than -1 is the range. Y is greater than or equal to -1 is the range. The domain is everything. So we'll just say -infinity to infinity. When you know these things, when you know how to shift these, you can get really good at these graphs, and it won't matter what function you're dealing with. You can deal with crazy functions. Here's kind of an arbitrary one. If I take this function, which I called f of x, and I add a number, well, that should cause a vertical shift. And let's see that it does. And look at that. If I change that value of k, I'm getting a vertical shift. What about if I change things inside the parentheses? If I change things inside the parentheses, then I should get a horizontal shift. And guess what? You get a horizontal shift. So these things are very predictable, and it's cool that you can graph them that way. Good luck to you with this stuff. We'll catch you for the next one.